Okay, right, so the key takeaway is, all that a firm is a technology of production attached to a profit motive. So what we're going to do next is we're going to talk about each of these two pieces. We're going to talk about the profit motive, and then we'll talk about what we mean by a technology of production. So when we say that a firm's trying to maximize profits, we're making a very simple statement. We're saying that the profits of a firm, pi, are just going to equal their total revenue minus their total costs. Right? This is going to be their level of profit. So when a firm is making a decision, like how much output to produce or what inputs to use, what they're going to do is they're going to choose the level of inputs and the level of output that lead to the largest possible difference between total revenue and total cost. Right? So if we say pi is a function of Q, which is output, let's say quantity of labor, quantity of capital, right, would equal the revenue that comes from selling Q units of output minus the costs associated with hiring L units of labor and K units of capital, right? And our goal is going to be to make this as large as possible. Okay, so in order to do this, in order to solve this problem, a firm essentially has to make two types of choices. They're going to have to solve two embedded problems. The first one, I'll call the CEO's problem. This is effectively the question, how much output do I want to produce? Right? In other words, we'll choose Q. And in order to solve that problem, right, we're going to balance the revenue we get from additional units of output against the cost of producing that output, right? The cost of inputs we need in order to produce that output. Now, in a more general sense, right, this would also include decisions about what output to produce, but for now we're going to assume there's just a single type of output that each firm produces. Okay. So this is kind of the CEO's problem. The second level problem, we'll call the plant manager's problem. Is going to be what inputs to use to produce the optimal level of output, the amount of output that the CEO asks for. How to make Q units as cheaply as possible. So we've taken Bob Barker now, and we've essentially split him not just into two people, but into three people, right? The actual human being, who we won't worry about too much. But then we basically said, in order to decide what a firm should do, there's two levels of decisions. You need to decide how much to produce, and then once the CEO has said, we're producing Q units of output, the plant manager needs to say, what's the best way to produce those Q units of output, right? What's the cheapest way of producing Q units of output? Okay, and in order to keep the problem manageable, at least for the time being, we're going to make a couple of simplifying assumptions. So the first assumption, which we've already talked about, right, is that we're only going to produce one type of output. And second, we're only going to consider two types of input. So in the real world, right, anything we want to produce, we're going to use a tremendous number of different things, right? If we wanted to grow wheat, for example, we might need land, we need seeds, we need fertilizer, we need people. We're going to say there's just two types of things you need. You need labor and output and capital. So two inputs, labor and capital. And I'll call labor L and I'll call capital K. So this is similar, right, to talking about leisure and consumption. These are going to lump together a whole bunch of different types of inputs. We're also going to assume that we essentially have a market economy for both inputs and for outputs. So that means that firms can buy as much labor and as much capital as they want for some given wage rate and rental rate. much as they want for prices, wage rate W, and rental rate R. And likewise, they can sell as much output as they want for some market price P. Awesome. Okay. Okay, great. So the other thing we need to talk about, right, to understand firms is what we mean when we say that firms have technologies of production, right? When we really say firms are technologies of production. So what a technology of production is fundamentally a way of turning inputs into outputs, right? So a way of turning labor and capital or land and seeds and all this different stuff into some output like wheat. So if we weren't simplifying the world, right, we might say that our production of wheat would be some function of, labor, seeds, land, right, tractors, et cetera, right, fertilizer, water, blah, 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 blah. Because we're going to work in a simple world where we only have two kinds of inputs, we're instead going to say that the amount of wheat we produce is just going to be some function of labor and capital, right? In this class, we'll always use these same two inputs. And so essentially what this means, right, what this F of LK means, is if I have L units of labor and K units of capital, how much wheat can I produce? Make sense? Cool. So let's think about a couple examples. Let's imagine first that in order to make a bushel of wheat, you needed two things. You needed to rent a threshing machine for an hour, and you needed to have a worker work for 2 hours, right? So let's say they need to ride the threshing machine for an hour, then they need to lug all of the bags of harvested wheat right onto some sort of a loading bay, right? So we'll say in order to make a bushel of wheat, we need 1 hour threshing machine, two hours labor. Worker time, which I'll call out. Right? And so we want to know if this is what it takes to produce a bushel of wheat, what is the production function for wheat, right? What's our F, L of K? Okay. So let's think about this for a minute. So we need to have, right, a fixed ratio of labor and capital. We can't do the threshing machine's job with workers. We can't do the workers' job with more threshing machines. So we can think about labor and capital in this context as being perfect complements, right? For effectively the same reason that we can think about goods, right? Bicycle chains and bicycle gears as being perfect complements, because they're only useful together and they're only useful in a fixed ratio. So if they're perfect complements, right, what we essentially need to know is if we have K units of capital and L units of labor, how many bushels worth of labor do we have? How many bushels worth of capital do we have? Right, so we'd say F of LK would equal the minimum, right, of bushels worth of labor and bushels worth of capital. So if we had, let's say, 4 labor hours, that would be enough to make 2 bushels, right? We'd take 4 divided by 2, since it takes 2 hours per bushel. So we'd say L over 2. And then how many bushels worth of threshing machine hours do we have? Just K, right? Awesome. So that would be my production function, right? And it would look and act in many ways similar to a utility function. Now, while it looks a lot like a utility function, there's a very important difference that I want to take a minute on. When we talked about utility functions, right? Let's say that I had 2 goods, right? And I wanted to say the utility of laptops and kaleidoscopes, right, was equal to the minimum of 1/2 L and K. Right, if I had a utility function like this, the number, right, the number of utils really doesn't mean anything. So this would be equivalent to right, let's say U of L and K equals min of L and 2K. Right, essentially I can multiply the whole thing by 2. I wouldn't change the meaning at all. Right, if I wanted to be wacky and crazy, I could even say it's equivalent to the minimum of L and 2K squared. Right, I can do any ordinal transformation. Right, because of the fact that the utility values don't have any meaning. Is that true of our production functions? Is this equivalent to f of L and K equals the minimum of L and 2K? Think about that for a second. So the meaning of this equation, right, how we got here, is we said to produce some amount of wheat, right, how much wheat can we produce with L hours and K units of capital? We can produce L over 2 bushels of wheat with our labor, K bushels of wheat with our capital. Since it takes both, our total production is the minimum of L over 2 and K, right? This, the minimum of L and 2K, is double this, right? So the output would be twice as large. And in this case, that would mean if this was our production function, we would produce twice as much wheat as if this is our production function. So these are not equivalent for the very simple reason that the meaning of our function here isn't utils, which is some arbitrary made up thing, it's bushels of wheat, which is a real thing, right? So because of the fact that our production is real, right, the value, the numbers that come out of this have a meaning, and it's a real thing in the real world, right, amounts of wheat. So the numbers matter, ordinal transformations are not going to be equivalent. Okay, so are labor and capital always going to be perfect complements? No, not necessarily, right? Just like we can have lots of different consumer decisions described by different types of utility functions, we can have different types of producer decisions described by different types of production functions. So now let's imagine, instead of a bushel of wheat taking 2 hours of labor and 1 hour with a threshing machine, let's imagine that we could either harvest a bushel of wheat just by sending people out in the field to pick the wheat themselves, right, or with some, extremely cheap capital that we can round down to 0, like a scythe or something, or we can use an ag Roomba that we just send out there, right? It's a fully autonomous machine designed with machine learning. It'll harvest the wheat itself, package it all up, send it off without any humans being involved at all, right? So let's say that we can either harvest a bushel of wheat with 5 hours of labor, or a half hour with the ag Roomba. Right? So in this case, if we have L hours of labor and K hours of ag Roomba time, how much wheat can we harvest? Well, the L hours of labor, right, would harvest L over 5 bushels of wheat, right? 1 bushel for every 5 hours of labor. And the K ag Roombas, right, hours of ag Roomba, would harvest K over 1/2. Right, or if you prefer 2K. Bushels of wheat. Right, so total, if I have L hours of labor and I've got K hours of ag Roomba time, I would be able to harvest L over 5 plus 2K bushels of wheat. Right? And this is going to be describing a situation where hours of labor and bushels of wheat are perfect substitutes. We'll end up with a production function describing perfect substitutes that looks just like our utility functions did when they were describing perfect substitutes. Cool. So, right, big takeaway when we talk about production functions, we're essentially telling ourselves how much output can we get with a certain amount of inputs, right? And the structure of those production functions are going to vary and describe different situations in the same exact way that the structure of our utility functions are going to describe different consumer decisions. Awesome.